Hi, in this video we're going to look at 5 crucial circle theorems you need to know for higher GCSE Maths. First, we're going to look at a level 8 problem, and I'm going to show you how to solve that problem using 4 of the 5 circle theorems. Then we're going to cover one extra circle theorem which I think you really should know for the exam. Before we get started, please click on the subscribe button and the bell icon. That way, when I put out videos on topics related with GCSE Maths, you will get notified. So first, let's look at our problem. We have a circle, which is good, given that this is a video about circle theorems. In that circle, we have a trapezoid quadrilateral, ABCD. A, B, C, and D are all points on the circle. The question states, find angle DCB given that ED and EB are tangents to the circle, and angle DEB is 80 degrees. Now I think circle problems are, shall we say, challenging. You can look at a problem like this and not know where to begin. So one approach is what I call kind of the blitz approach, is to start putting stuff down that you know. What I've found when you do this is that usually the answer kind of just pops out. So this is what we're going to do here, and something I strongly recommend. We have been told that ED and EB are tangents. Now the definition of a tangent is a line that touches a circle at one point and one point only. This brings us to the first circle theorem, which states if O is the center of a circle, a line drawn from here to the point where the tangent line touches the circle makes an angle of 90 degrees with the tangent. We can draw this in. If we put in a line, then we can see that two triangles are formed which are congruent. That means same size, same angles. This is the other theorem to do with tangents. They form a pair of congruent triangles. So to review, we have covered, while answering this question so far, 2 circles theorems. The first one being that tangents make an angle of 90 degrees to the lines drawn from the center of the circle to the points, and secondly, a pair of tangents form 2 congruent triangles, that is, same size and same angle. This is all great, but does it take us closer to finding the angle? Well, my suggested approach would be to put in the angles you do know, and usually when you do this, you can work out the angles you don't know. So I definitely recommend you draw on a diagram or a sketch of the circle. Applying this approach, we know that angle DEB is 80 degrees. But we can also say that angle OEB and angle DEO are 40 degrees. Why? Because from the circle theorem, these two angles should be the same, and because they're a pair of congruent triangles, and the only way they can be the same and combine to 80 is if they are 40 degrees. A fact you should know, which isn't a circle theorem, well, because it applies to triangles, so it's kind of a triangle theorem, as it were, is that the angles in a triangle add up to 180 degrees, and this applies to any triangle. Therefore, taking our pair of congruent triangles, in both of them we have angles of 90 degrees and 40 degrees, which in total comes to 130 degrees, so the remaining angle must be 50 degrees, because 130 plus 50 is 180. So we have a pair of angles at the origin, each 50 degrees, which makes 100 degrees in total. This brings us to our third circle theorem. The angle made by 2 lines drawn from 2 points in a circle at the origin is twice the angle made by 2 lines from 2 points to a third point on the circumference. Therefore, in our case, we have 2 points B and D, and we have lines drawn from them which form the basis of our right angle congruent triangles. They form an angle of 100 degrees, made up of the two 50-degree angles we talked about previously. This is the angle subtended or made at the origin. We have another point, A, which is on the circumference, again mentioned in the theory. Repeating the circle theorem, the angle made at the origin is twice the angle made at the circumference. So the angle made at the origin is 100 degrees, so this angle at the circumference will be 50 degrees. This brings us to our fourth circle theorem. Opposite angles in a cyclic quadrilateral add to 180 degrees. A cyclic quadrilateral is one where the corners touch the circumference of the circle. In our case, we have an angle of 50 degrees, angle DAB. The opposite angle in our quadrilateral happens to be DCB, the angle we're looking for, so it must be 130 degrees because 130 degrees plus 50 degrees makes 180 degrees. Therefore, the answer to the question is 130 degrees. To recap, we used firstly the circle theorem that tangents make an angle of 90 degrees with lines drawn from the origin. Then we used the second circle theorem that a pair of tangents that meet at a point form congruent triangles. The third theorem we used is that the angle made by lines drawn from points on the circumference is twice at the origin what it is at another point on the circumference. And finally, the fourth theorem we used is that opposite angles in a cyclic quadrilateral add to 180 degrees. The fifth bonus circle theorem, as it were, we are going to talk about is the alternate segment theorem. It's one that I think some people struggle with. That's why I'm covering it here. But what I'm going to try and do is make it as simple as possible. Firstly, we have a tangent to the circle. Remember, a tangent is a line which touches the circle at one point and one point only. We also have a chord. Now, chord is a fancy name for a line that's within the circle that touches it at 2 points. One of the points our chord touches the circle is the same place that the tangent touches the circle. So, there is an angle made between the chord and the tangent. All that this theorem says is that this angle is the same as the angle made by the two lines drawn from the ends of the chord which meet at another point on the circumference of the circle. These lines, together with the chord, make a triangle. This area where the two lines are is also called the alternate segment. So, saying again, the key thing to remember is the angle made by these two lines at this point is the same as the angle between the tangent and the chord. So, typically where you would look to use this is in a question where there's a triangle within the circle, and there's a tangent, and the triangle meets the tangent. This theorem will help you identify at least one of the angles in that triangle. This brings us to the end of this video on circle theorems. We covered 5 circle theorems. We looked at how to use 4 of these circle theorems to solve a GCSE level question, and additionally I gave you a 5th circle theorem, which was the alternate segment theorem. Thanks for watching, and like or subscribe this video if you found it useful.